Hey everybody! Today we're going to be talking about similar triangles. So very similar ideas that were in the last section. Now we're going to focus specifically on triangles, and basically what we're going to talk about are three different versions of ways that we can prove triangles are similar other than just solely relying on all the sides being proportionate. So there are three that we're going to talk about. Some of them are going to be new, some of them are going to be familiar. Just make sure you write them down, draw the pictures, and then you should be good to go. So the first one that we're going to talk about is the angle-angle similarity theorem. And this just tells you that if you have two triangles, if two angles are congruent, then those triangles have to be similar. So here I've got two triangles, triangle ABC and then triangle HJI. And all I notice is that angle A is congruent to angle J and angle C is congruent to angle H. So automatically, because these have two congruent angles, I would know that my triangle ABC, move this up, is going to be similar, and I got to go in the same order, to triangle JIH. And then I'd be done. So there's my similarity statement, all because we've got two angles that are congruent. All right. Same concept with this one. So here's two triangles, DPE and KLT. Now what you notice is they both have right angles. Okay, so what you want to be careful of, especially if you're given measurements instead of just markings, is to make sure that you know what all the angles are, and then make sure to see if there are at least two that match. So in this problem, they both have a right angle, so we already know one angle is matched up. But here we've got a 44 and here we've got a 47. So notice they're not the same parts of the triangle, at least it doesn't seem it. So what I would suggest doing is figuring out what measure goes in this bottom angle. Well, if we go ahead and subtract 180 minus 90, that gets us 90. Okay, and then if we subtract 90 minus 47, we end up getting that this angle here is 43 degrees. All right, so we know that that's 43 degrees. Well, automatically we know that 43 is not either of these. And if you weren't sure, double check what should be in this picture. Okay, if I take 90 minus 44, I'm going to end up getting 46. So only one angle matches up, the 90s. So that means that this is not going to be a similar pair of triangles. So not similar. And the reason, no, don't have two angles that are congruent. Okay, so some kind of statement like that is enough to be able to write that they are not similar. And you'll have to do something just like this on your assignment for this section, right? Next one that we're going to talk about is the side-side-side similarity theorem. Now, remember when we talked about side-side-side last semester, that it meant if all the angles were congruent, or sorry, if all the sides were congruent, they were congruent triangles. Well, here we don't care about congruent because these triangles will not be the same size. What we care about is that all of the sides are proportional. So we need to make sure we check every single set of sides and make sure they end up getting the same thing. Now, if you don't have a similarity statement, easiest thing to do when you're trying to match things up is go with the largest go together, the smallest go together, and then the middle ones go together. So for example, JK is the largest side on this side, so it's going to be 16. You have to bear with me as I have to type this out. So 16. And then over the largest side on this side, on the smaller triangle, is QP, and that's 12. All right, so if we reduce that, we can divide both of them by 4, so we get 4/3. Okay, so that's for the first triangle. And then we can do the same thing for the other side. So the next largest is 12, and 12 is going to match up with 9. And if we reduce that fraction, so 12 over 9 reduces and we get 4/3. So far we're on the right track because so far both the proportions, so both the sides have the same ratio. And then last side, we're going to do the smallest sides. So LK is the smallest side of the large triangle, and then 6 is the small side here. So if we reduce that, both can be reduced by 2, so we get 4/3 as well. So notice that every single ratio for each side they're all 4/3, which means that this is a similar set of triangles. So we would say that triangle JLK is similar to triangle, and we have to make sure we go in the same order. So we would say it's QPM. So there would be your similarity statement. Okay, so you have to write a ratio of each side and compare them after you've reduced to make sure and see if they're the same, or they're similar, sorry. Last one we're going to talk about is the side angle side theorem. So this is if you are wanting to show that two triangles are similar with sides and angles. This kind of combines a mixture of the first rule and the second rule. So here we want to be looking for two sides that are proportional, and I have this description here, as well as the included angle being congruent. So remember, when it says included angle, that means the angle has to be between the two sides. That's very important. Notice the A is between the two S's. So in the picture, the angles that are marked or are congruent have to be between the two sides. So we've got this picture down here. Now notice there's no angles marked. However, think back to first semester, we said we can always mark vertical angles. So right away we know those are the same. And now we just have to go ahead and compare our sides to see if they're proportionate. Because remember, we don't want them to be equal, but we want them to have the same ratio. So I'm going to start with the 22. Do this in blue. So 22 is going to go, that's the largest side of the right triangle, so it's going to go with the largest side of the smaller one, so that's 11. So 22 over 11, that reduces to 2 over 1. Okay, and then do the same thing with the smaller triangle, so, or smaller side, so that's 20, and if we put that over 10, when we reduce that, we get 2 over 1 as well. So notice these are both going to have two similar sides and then a pair of angles. So we can now say that in this problem, triangle TWZ is similar to triangle YWX. Okay, and remember, any of your similarity statements, the order matters, so you want to be careful you follow the same order for both. Okay, so in this particular problem, we are looking at two different triangles, all right? We're looking at this smaller triangle here, QMN, so I'll highlight this in green, okay? And then we're also looking at the largest triangle, PM, what is that, O, okay? So two triangles, the top one and then the whole large one. And what we're going to be doing is setting up a proportion in order to identify what QP and MP are. All right, so we're asking for a whole big side length. So when we look at this, first I need to identify what sides could be used to set up a proportion. So notice that here I have MQ, okay, so that's one side of the small triangle, and I can relate that to the same side that's on the larger triangle, okay, so I'm going to go ahead and set up the first part of my ratio, so it's going to be, I'm going to do smallest over largest, so it's going to be 5, and then over the whole length, you just have to add these two things together, so it would be 5 plus X, and let me put my little fraction bar here, okay, oops, okay, so there's our first fraction. And then we're going to make this equal to, and we're going to do the same thing on the other side. So I'm going to say that this MN is going to be a ratio with the largest one. So here we would have in our fraction the smaller side, so that's 6. And then over, let's see, 3 and the whole thing, add 6 and 3 3/5. That's going to get you 9 and 3/5. Okay, so it's kind of hard to type mixed numbers on there, but you guys get the idea. So now we have this nice problem, so we can go ahead and start to cross multiply. So if I cross multiply, I'm going to do these diagonals first. So here, so when I cross multiply, 6 times 5 is 30. And then 6 times 6x is just 6x. And that's going to be equal to, so now I have 9 and 3/5. If it's easier for you to type this in as a mixed number, that's okay. All you have to do is take 9 times 5, which is 45, plus 3. So you get 48 over 5. That's the 9 3/5 times 5. And that's going to get you 48. Okay, and now we have an equation that is solvable. So that 48 came from these two right here. Okay, so now we just solve. So when I solve this, I'm going to subtract 30 over. So I get 6x equals 18. And then lastly, x equals 3. So we found what x was, and that's great. But they want what QP and MP are. Well, it's very handy that QP is x. So for our final answer, we could say QP equals 3, because that's what x was. And then they want MP. Well, MP is 5 plus x, because it's the whole thing. So it would be 5 plus 3, which gets us 8. So there's our two answers. So QP and MP. And then you'd be done. Okay, so it's still proportions. And the reason we can do that in this one is because these two triangles are similar, and the reason we know they're similar, even though they haven't told us that, is because we can say that because these lines are parallel, now we know that some angles are the same. So notice these two angles would go together. And then also, because we've got parallel lines, these two angles here and here would go together because these are all corresponding angles. So automatically we have an angle type situation. So that's one of the first rules that we learned. And that's why we're allowed to set up proportions like we did. Okay, if they weren't similar, we couldn't set up a proportion. All right, last problem, and then I will let you guys get started on your work. It says Josh wanted to measure the height of the Sears Tower in Chicago. All right, and he said he used a 12-foot light pole and measured its shadow at 1 o'clock. All right, and it says the length of the shadow was 2 feet. So here on this picture, I'll mark on this. Here's the light pole, okay, and then here's the shadow. So we've got this little tiny triangle here that I just marked in red. And then it said later, or at the same time of day, he measured the Sears Tower shadow and found that it was 242. So that's this whole length right here. It was the whole bottom part. And what they want to know is, what's the height of the Sears Tower? So what we're looking for is this that I just marked on in green. So notice we have two triangles here. We have this little tiny one in red, and then we have this whole big one in green that I just marked over. So we know they're similar, all right? They share some sides, they share some angle measures, so we can go ahead and set up a proportion. So I'm going to work with the bottom of our triangles first. So notice that this little triangle has a length of 2, okay? And the bottom of the largest triangle has a length of 242. So I'll write that as a fraction. And remember, you always go triangle to triangle. So there's our first. And then we're going to do the same thing. We're going to make that triangle, or that proportion, equal to. Now we're going to do the height of each triangle. So this height here, I started with the small one, was 12. And we're going to make that over the height of the other triangle, which we don't know. So we'll just put x. So there's our proportion, and so now we just have to go ahead and cross multiply. So cross multiply those, and we get 2x, and then cross multiply the other side. So 242 times 12, that's going to get you 2,904. So let me type that in there. And now all we have to do is divide by 2, and that gets us that the height, okay, so this is x, of the Sears Tower is going to be 1,452 feet tall. So this is a perfect example where units are very important. You just got to set up a proportion and then solve for your missing variable. And of course, if they ask you to plug anything back in, make sure you do that. So the reason we can set up all of these proportions is because we're assuming or being able to find that the triangles are similar, and we're using either side, 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 side angle, side, or angle, angle. All right. So if you have any questions on either of the 3 rules or how to set up the proportions, let me know. Otherwise, you are good to go. Thanks for listening.